I've just loaded up into laser cut 6.1 actually. A dithered swash or bar test CAD that you can download straight from Google. All you need to put in Google is dithered image, and these sort of things come up. Now, when you get a new machine or when you're getting used to your laser, you need to find out what its parameters are, because every laser is different. Now, yesterday, on the last video, we've actually found out the minimum that the laser would fire at, which was 10%. And the maximum we know on the scale within laser cut is 85%, which relates to 100 watts. So what we are going to do today is we are going to find out the parameters that we can use with this laser for dithering a picture or a photograph. But before we, you just can't get a photograph and put it into laser cut and get a perfect result. You've got to work your way up to it. So we're going to start off with a test CAD. I'm going to run this through laser cut, and we will try different parameters to see what the best result is for this laser in different materials. And it is only then that you can make a perfect picture in whatever material you require, whether it be glass, acrylic, in softwood, hardwood. They are going to have different settings, so we're going to find out some of those settings in this video. Okay, I've just found another swatch actually, which it better represents what I'm looking for. Absolute definite areas instead of one area washing into another. I wasn't quite happy with the outcome of the other one. I stopped it after just a minute actually. So we're going to reset this one. Now I've set it for 400 speed of 400 millimeters a second, minimum power 15, maximum power 25, and we'll calculate that. And we'll send that to the machine and cut that. I think that's a better representation of what I'm looking for. Okay, I've run this test CAD or swatch. This is the third time now, and you can see I've done 1525, 1220, and 1117. So I just want to see what happens here. Okay, so what you're actually looking at here is a magnified part of, well, I'll lift this up and show you. So that's it there, and we're looking at this edge here, this corner here, and this is at 1525 percent setting of the power, running at 400 millimeters a second. So there you are, to give you some idea of how much magnification there is here. There's quite a bit, and we're looking at that, and this is 0.09 of a step over, so it's slightly less than 1/10 of a millimeter step over, and you can only just make out the lines of the laser. In actual fact, in real life, you can't make out what it is. I'll bring it up close to the camera, but of course under the microscope you can just barely make out some scan lines. So really they matter not. So now I'm going to show you something pretty incredible. Now here the laser hasn't fired at all in this square, at least nothing you can detect. And then we move along a little bit, and then look at that. Each one of those marks the laser has made individual firings at. I'm going to zoom in a bit closer. It may look disorganized, but in actual fact it's an organized pattern. It directly matches up with, well, the pattern on the picture. Now this is operating, the laser is running at 400 millimeters a second. Each one of those dots is 0.2 millimeters in diameter, or thereabouts, maybe slightly less. So that's incredibly quick that laser has to switch on and switch off to burn each individual spot. In actual fact, it's about a millisecond, approximately. So to give you some idea of how quick this laser can actually operate at. Now moving along to the next square, and you see the graduation from switching from one section to the next section. There's a defined line here, as there is a defined line here, into like the dot matrix, into a deeper or darker pattern. And then again it's less defined, but it is actually, hang on, if I can make it out, it should be in the middle of the picture, which is there. So from this to that, and so on. Even more dense. Even more dense. If I just keep the bottom, this is what we've already seen. This is the new. This is getting denser and denser. So you can see there's less and less areas affected by the laser until we get to total area of machine. So this laser is able to operate over the entire spectrum from 15 to 25. It is able to actually operate over that spectrum. So Okay, so this is that piece of pine boarding that I just run the same test into, and it's quite spectacular, really. It's quite surprising. Now, this is the deepest cut, so this is running at 20%. Okay, so we'll run backwards on this. Okay, it's slightly getting less, and there's a bit of a change there to less, even less, and even less again. If I can hold this microscope steady, moving down, and it's near identical to what it was, the representation in the hardboard actually. And I don't know whether you're noticing something here, but there's no muck. I don't know why. I think the level of smoke that was coming off it, which was very low actually, the jet and the extraction system was just managing to keep up. I'm going to have to do some tests on it to find out exactly what was going on, but there's no evidence of any residue whatsoever. This is laser cut 6.1, so what we're going to do is go to here and import the Tiger photograph. It's already been dithered. This is straight off the internet. Now, I don't know how this is going to come out, but we're about to find out. So what I'm going to do is get the highlighter, and we're going to resize this. I think I'll make it slightly larger, because if it turns out pretty good, I'd like to sort of have a decent picture of it. Although this is only in B supply, it'll be nice for the first one, I think. Okay. You notice I kept the aspect ratio ticked so it doesn't go out of shape. It looks a bit messy, but I think it'll turn out okay, actually. So we'll go to engraving, and 2012, it's already set 2012 from the last time. By direction, blowing, we'll have blowing. We'll press OK. So now we'll send it to them, and look, setting up a program to be laser cut in laser cut program, it's as simple as that. You can use Paint Shop or something like that to just take a photograph, and with one click of a button really you can convert it to a grayscale dithered picture. There's no great mystery in that. So, but I will do a video of just doing that, actually preparing a picture, a standard photograph, and setting it up to a dithered picture like this, and we'll cut it. So for now we're going to send this one to the machine and set up and cut it. So there's the dithered image on the, as it appears on the computer. Anyway, and this was just cut into plywood at power level at 1220. So that's minimum, maximum well, it is here, and a speed of 400 millimeters a second. Well, it didn't quite come out. Probably could have come out quite a bit dark. It might have been very much better, but inadvertently those settings I have discovered are perfect for paper. Absolutely perfect for paper. So we've had a fairly big win today. We found that we have actually found the correct settings for etching into paper. That probably would have needed about 15-25 to etch into that wood. But I just thought, I think I'm going to bring this video to an end here, because, we've got a big win here. Okay, so that was quite a win today to find out the best setting for paper. This is 100 gram paper. It's an A3 size. You can get this type of paper from any artist's outlet. I buy a book of 100 pages normally. I think I'll try a different picture at a different setting. I'll try several different settings, because I really want to find the correct setting to etch it into this type of pine, and also I want to find out in hardwood and real pine, and some exotic woods as well. But it's a fairly easy process to translate then a dithered picture into a picture that the laser can understand and cut, as it were, or etch. So I hope you've enjoyed this video today of finding our way, and I hope you come and see me again for the next video. So you can choose whichever. So I hope you visit both my channels, the Australian Inventors Workshop, which deal with CNC routers and wood lathes and different shop jobs that I do around here. There's 200 videos on that channel, and of course the Australian Inventors Laser Lab. So all I've got to say now is bye for now. Oh, and by the way, I did run the camera and filmed best part of the produce. I did run the camera, and I filmed pretty well all of this. So what I'll do is at the end of this video is I'll put a very fast, sort of 16 times speed, something like that, so you can see this picture appear. So that'll be directly after this, just before the credits. Okay, so bye for now.